Here we're going to solve a square root equation, and this equation has two square roots in it. So the general approach is going to be, we're going to choose one of the roots to isolate. Doesn't matter which one. I'll just pick this first one. We're going to isolate the root, square both sides of the equation, then isolate the other root that's left, square both sides of the equation again, and then solve for x. Alright, so let's go ahead. We'll isolate square root of x plus 5. Which means we need to add root x minus 3 to both sides of the equation so that it cancels on the left. And that gives us root x plus 5 on the left equals 2 plus square root of x minus 3. And now we have an isolated root. As soon as we have an isolated root, we can square both sides of the equation. And that'll get one of our roots to go away. So if we square this square root, we get the insides out, which would be x plus 5 equals, and now we have this entire quantity squared. Now be really careful here not to say 2 squared plus square root of x minus 3 squared. You actually have to write it multiplied by itself, which means you're going to have to FOIL it out. So we're going to end up getting a middle term that we would lose if we just distributed the exponent, because we cannot distribute exponents over addition or subtraction. Alright, so we have 2 plus root x minus 3 times itself, so we have to FOIL that out, so it's going to be a pretty long expression. FOILing it out, we get 2 times 2 is 4, plus 2 root x minus 3, plus 2 root x minus 3 again for the insides. And for the outer terms, we get root x minus 3 times itself. So plus root x minus 3 squared. And let's simplify what we have. We can first of all combine like radicals because they have the same index and the same insides. So we get x plus 5 is equal to 4 plus, and we can combine their coefficients, plus 4 root x minus 3. And then if we have a square root being squared, we're going to get the insides out. So that gives us plus x minus 3. And now we want to keep simplifying a little bit, and then we'll isolate this other root that's here. So simplifying a little bit more, we have like terms 4 minus 3, so we can combine those. And now we get x plus 5 is equal to 4 minus 3 is 1. Plus, and I'm just going to bring down the rest of the stuff, 4 square root x minus 3 plus x. Alright, now it's time to isolate this second root. So we'll start by subtracting 1 from both sides and subtract x from both sides. So it cancels on the right, and it also happens to cancel on the left. And we get 5 minus 1 is 4 equals 4 square root x minus 3, and we're almost there. I notice that if I divide both sides by 4, I won't have a fraction on the left, I'll just have an integer, so that's nice. I'm going to go ahead and do that. Divide by 4 on both sides, and we get 1 is equal to root x minus 3. We have an isolated root, that means we can square both sides, and we get 1 is equal to, and the insides come out, x minus 3. And now we keep solving for x, adding 3 to both sides. 4 is equal to x. And there's our solution. But as always, with the square root equation, we want to check the solution and make sure that it's not an extraneous solution. So we're going to put x equals 4 into the original equation, which was root x plus 5 minus root x minus 3 equal 2. So the question is, does the square root of 4 instead of x plus 5 minus square root of 4 minus 3, does that equal 2? And this would be root 9 minus root 1. Does that equal 2? And this is 3 minus 1, so yes. We get 2 equals 2, which is true. Therefore, x equals 4 is a valid solution.